All right, so we have an RC circuit here. The voltage on the battery is 12 volts. We have a current passing through, um, the resistor, as we're told. And so let's just draw a schematic of the battery in part A. So we'll draw a battery here. We'll put 12 volts on it. And then we'll have a switch here, and then we'll connect our resistor and our capacitor like this. You know what, before we do that though, let's do the following. Let's have the switch, and then I'm going to put an ammeter here that can measure current going through a resistor, and we can put the capacitor like this, so we can make this a very simple series RC circuit. All right. Now it says, having obtained the curve above, determine the value of the resistor that you placed in this circuit. Well, at time equals 0, the capacitor is just starting to acquire charge, so it behaves like a wire. So that means the current in the resistor is going to be the EMF of the battery divided by R. Another way to see that is you can plug in 0 for T here. And so what we're getting is that 0.01 amps equals the 12 volts of the battery divided by R. So when we isolate R, we can take 12 divided by 0.01, and the result that we will get is going to be 1200 ohms of resistance. Okay. What capacitance did you insert in the circuit to get the result above? Well, let's remember the time constant equals R times C for a capacitor, and in this case, that's 4. So 4 equals 1200 times C, so that'll be 4 over 1200 equals C. So that gives us 0. Let's get those decimal places again. 1, 2, 3. So 3. Let's try that again. 3.33 times 10 to the negative third farads. You might see a textbook write this as 3,333 microfarads. If I have that right. So that's part C. Then for part D, it says this is our circuit. We would draw a schematic that would produce the graph above. Well, we have a charging and then a discharging capacitor. So I think this is going to be that situation that we've talked about before, where we have a switch that can go 2 ways. So let's put our resistor here and our capacitor here, and we'll hook up a battery like this. And so we'll have a switch that can either close, we'll call this A, we'll call this B, and our switch is like this. So that is the schematic. Let's make absolutely sure we have this right. So this will charge it. No, got that switch just a little bit off. We'll put the switch here, and then this is B, and so we will be, so once again, to get this right, this point here will be A, this will be the switch, so that when we're at A, we're charging, and when we're at B, we would be discharging. So again, here's our EMF, here's our resistor, here's our capacitor, and I guess if we're going to measure the voltage across the capacitor, we would want a voltmeter in parallel with it right here. All right, so that is part D. That is 2003 E&M question number 2.